to learn about measurement, we cannot learn about the units, right? The unit is really important. And I'm going to convince you that unit is really important. Let's take a look here, okay? So let's say we're in San Diego. Well, some of you are. And let's say if we have to drive from San Diego to San Francisco, how far is it? So San Diego is down there, San Francisco is up there. Okay. Well, I ask many of my students this question, and I usually get these two answers. Some of them gonna say, "Oh, it's about 7.5 hours away." That's Google Maps said 7 hours, 37 minutes. Right. The other group of students will say this, "No, no, no, no. It's about 500 miles away." I'll be like, "What? Are you guys talking about the same thing here?" Well, the correct answer from for this question is how long, right? So it's gonna be miles, about 500 miles. But in America, maybe in Canada, and maybe in some places, but not as common, we use time as a measure of distance. Does it make sense? So basically, in this case, both answers correct, right? And but I mean, it creates some confusion in here. If you go out to other countries, no one will use time as a measure of distance. How far is point A to point B? It's about 3 hours drive. It's like, okay, they're gonna be confused a little. Like, okay, 3 hours. How many miles is that? How many? Oh, they don't even use miles. They use kilometers. So anyway, let's say 32 degrees in our country is cold, but the same degree, 32 degrees in Japan. Dude, that's hot. What's going on here? Well, that's a different unit. Go. One is Fahrenheit, one is degrees Celsius, and 32 degrees Fahrenheit is 32 degrees Celsius is 90 degrees Fahrenheit. That's really hot. Okay, so use a different unit and create quite a bit of confusion. One more time, my car can run 220 miles per hour. The other guy say, nah, mine's faster. It runs 30 meters per second. Are you guys talking about the same thing here? So when you compare a measurement unit to unit, you probably need to have the same unit here, right? You want to compare apple to apple, you can't compare apple and orange. It doesn't make any sense. So to eliminate this confusion, about 20-30 years ago, so all scientists around the world gathered together in Paris, right, and come up with, all right, let's talk about the unit all of us will use together. Okay, so we don't have like one person talk about one unit, the other person talk about different unit. All right, so all of us talk about the same unit here. So if you talk about mass, use kilograms. Okay, there are 7 total. We call I can't say it, a systematic international unit. That's in English, right? That's the French. I can't say that. Anyway, so there are 7 SI based unit. This is a basic unit. There are 7 total, right? And so mass, use kilogram. Length, what do you know? What do we use for length? Not kilometer, it's meter. Okay, in meter. Time, we use second. Okay, not hours, not minutes, we use second. Temperature, we use Kelvin. Electrical current, we use ampere. You probably heard the word ampere before. The amount of substance, this is in chemistry, we use mole. Okay, you can write MOLE, that's the full, the short MOL, just ignore the E, that's fine. All right, so we're gonna spend a lot of time on this guy, mole, right here. And the intensity of light, so luminous intensity, candela or CD. Okay, so there are 7 SI based units that we're gonna use in this course, but we're gonna spend most of the time in here. Right, physics gonna be right here. It's physics, right? So chemistry we go right here. Mass and amount of substance in mole. We also have SI derived unit, which is use this base unit to make other unit. I'll give you some example. If you still remember length, what's the SI unit of length? In meter, right? So length times length, you get an area. So the SI unit of area is meter square, not centimeter square, not decimeter square. It's meter and meter, so meter square. And if we have length times another length, we get volume, right? And the SI unit of volume is meter cube. Okay, not centimeter cube, not milliliter, not liter. Okay, not quarts or ounces. Like that doesn't make any sense in here. All right. I did a little bit from physics. So force equal to ma. If you remember, mass times acceleration. What's the SI unit of force? Well, take a look at this right here. So m is kilograms. Yep. And a is meter per second square. Okay, so it's kilogram times meter per second square. That's an SI unit of force, but it's too long, so we just call it Newton. You probably have heard Newton before. Work, energy, heat, they have the same unit. So let's say work is equal to force times distance. So force right here, this is the unit of force, kilogram times meter per second square. So right here, kilogram meter per second square. And the SI unit of distance is meter. So the whole thing is kilogram times meter square per second square. That's the SI unit of energy, work, and heat. But we call it just easy joule. Lastly, power. What's the SI unit of power? Well, look at the formula. Power is force times distance divided by time per time. Okay, so the top one, force times distance is joule. It's joule per second. So we call watt. All right. Okay, so that's an SI unit. Next one, we're going to talk about the prefixes for this SI unit. There's a lot of it. Here we go.